here in Slovenia team. Welcome to our 5th meetup this season. We're very glad that so many of you joined us today. We have a very interesting topic, so convergence of AI, data, and blockchain. Sounds very buzzwordish, but I'm sure that Philip and Matej will show you some very interesting business use cases, and I'm sure you will enjoy it. And of course, as usual, pizza and drinks are following that. So for starters, I would like to invite Matej Janeš from Oasis to start with his talk, and then Philip will take it from him. Thank you.
Thank you, Žiga. So I guess I'm the starters and Philip is the main course then, or how we're going to call it. So it's very, how should we say it, hypey. You know, I even went further with the title, The Future of AI, right? Trustless, private, verifiable. And it might sound hyperbolic, right? But AI is evolving at an extraordinary pace, right? And we are at the crossroad between, having a centralized or decentralized approach. So today we're going to explore a little bit, how we can build systems that respect privacy, ensure transparency, and preserve human autonomy in the future. Before we dive into it, I'm Matej. I'm the head of partnerships at Oasis. I've been with the team for about 3 years now. I've been in crypto since 2017. It's crazy to think now this is already 8 years, but here we are. And I think we're just getting started for real. If we look at the current AI landscape, right? AI has been around since the 90s, but in narrow applications. And I think back then it was more called machine learning, right? Now machine learning is kind of one of the subsets of what we call AI. But then 2 years ago, I think it was, or even more than 2 years ago already, ChatGPT launched and AI really came to the forefront. Everybody started using it, and we are kind of reaching that tipping point, right, of widespread adoption. Like even I'm here, if I'm preaching, I need to use it as well. And you can see in the bottom right corner, this presentation was made by Gamma as well. No plug here. I'm not being paid, so no ad. But I did use an AI presentation maker to enhance kind of the whole slideshow. And you can tell me in the end if it was better or not, or how it was. But with all of the developments, right, and all of this acceleration, what we're getting is power concentration, right? So computer power capabilities, right, in the hands of a few, and that we see, as a little bit of a problem. We are in crypto because we want decentralization, we want trustlessness, and thankfully, right, in our ecosystem, new alternatives, right, are popping up. Decentralized options are in development. So if we touch on first on the centralized AI, as the word says it's centralized, right? It's dominated by a few key players like Google, OpenAI, Anthropic, Meta. The Chinese are also, getting better and better, Alibaba, DeepSeek. And of course, they have many advantages, right? Economies of scale, access to data from other applications, rapid development, access to talent, right? There are also disadvantages. And those disadvantages are mostly to the detriment of the user, right? Data privacy concerns, monopoly over AI, risk of bias, right? And how we can tackle that is, through the decentralized AI approach, right? So removing single points of failure, adding transparency, users control their data. So the advantages here, obviously, control of data, enhanced privacy, less potential for bias. But we are finding, challenges with the development in crypto with lower performance, slower coordination, right, and lack of standardization. But user self-sovereignty is very important, right? So data ownership, where people have control over and consent, over their data and their individual choices. Transparency, so clear visibility into data use and AI decision making, and of course value recognition, right? So personal data is valuable, and users should be included in the AI economy. So let's not copy what happened in Web 2, where our data was being monetized by the few, right? But bring monetization to the end users as well. So if we look at a quick comparison between centralized and decentralized AI, right? So on the data control, we have data breaches from this centralized AI and user control sharing on the centralized aspect. On the privacy side, you have surveillance and profiling from the centralized side. And here on the decentralized side, you have enhanced protection. And on the governance, lack of transparency. It's basically black boxes that we don't know about, how the decisions are being made, what's being done in there. And with this decentralized AI, you have the distributed decision making and community governance. And a lot of people here will say, well, I don't really care, right? My data, they can have it. I don't care how I get the end result. So let's just leave it like that. It's working fine. But we need to think, a few steps forward. ASI, artificial super intelligence, right, is arriving faster than expected, and how are we going to be able to compete with that, right? And then we need to come with, human super intelligence to be able to actually compete with ASI. How is that? Probably with some sort of BCI, so brain computer interfaces. You have Neuralink, you have different less invasive possibilities, right? But there will be a need for humans to enhance themselves to be able to compete, right? And that comes then with enhanced learning, AI-powered skill development and decision making. But then, with all that AI added to you, right, it's a question of cognitive liberty, right? How do you assure that the devices that you're using are not manipulating you, right? So manipulation protection, freedom of thought, right? Who's putting, because even we saw it, right, with social media, how influenced people were able to be through just social posts, right? Cambridge Analytica was a huge scandal, right, with Facebook. And then think about if you have an AI, let's say a personal assistant, that's giving you a biased view, it probably can make you do anything, right? Or maybe not the bunch here, right? But let's say people that are not aware of this. So why then go the decentralized approach? Because we can ensure that we have all of these three things covered, right? So freedom of thought, personal AI assistants under our control, not corporate oversight and manipulation protection. And as we can see from the landscape, this was done a few months back. So probably it's not completely valid anymore. We have many more projects already active, but we see a lot of different sectors popping up, right? From decentralized compute, confidential compute, agents, monetization of data, predictions, and as I said, this was done November 2024, so almost a century ago for crypto and AI development. And where we come in here is on the confidential compute side, right? So what is Oasis? Oasis is privacy for Web3 and AI. We are a public blockchain, right, that have confidential runtimes powered by TEs. And the additional interesting product that we're working on now is what we call the Raffle framework, which extends on-chain capabilities to off-chain compute. And I'll dive in deeper in the next slides. But maybe I go just through a quick origin story about Oasis. So we started back in 2018 as a layer 1 blockchain. We already started back then with a unique layered architecture with native layer 2s. So how we see now how Ethereum developed, with compute going to layer 2s and Ethereum becoming more the consensus layer. This is where we started back in 2018 and went mainnet in 2020. And smart privacy was always at the core of our, let's say, of our values. We started with Rust-based Veritime, private runtime. And then we switched to Sapphire in 2023. So that's almost 2 years. 2 years ago. 2 years, March 2023. So March 2025, 2 years. And Sapphire is meant to better serve the developers in the crypto ecosystem. Why is that? Because Sapphire is still, I think, it was the first and still the only EVM compatible confidential runtime in production. So you're developing in EVM in Solidity with the added confidentiality features that Sapphire brings. And it's not all about native development on Sapphire. We have cross-chain solution that we call the Oasis privacy layer, which enables you to use Sapphire features on other chains as well. And Raffle, which brings Sapphire's privacy features and verifiability to. Oh, you see, hey, I made a mistake here, and I didn't even see it. It brings Sapphire's capabilities to off-chain compute. If we look at ROFL, so ROFL, runtime off-chain logic. It's intended ROFL as the acronym. We want to have fun while we're in crypto. But what it does, it leverages TEs for security paired with Sapphire, with our Sapphire blockchain for on-chain verifiability. It has flexible computation, right? So enables deterministic applications APIs, that blockchains can handle. So it extends your compute, and it has the verifiable security, right? Because what we saw, right now, TEs being thrown left and right, people just throw stuff in the TE and think it's done, right? But it actually is important who has control over that TE, right? So how ROFL works, I can show you this. I'm not going to go into details of this, right? But it's very simple, right? We made it as simple as just run Oasis ROFL build and then Oasis ROFL build verify to kind of abstract away all this. So for this crowd, if you summarize it, maybe in a few bullet points, what ROFL does, it does TE provisioning, right? Oasis nodes provide provision into IGS and TDXDs for ROFL applications. It does the on-chain registration of a ROFL app to establish identity, and then the application interacts with smart contracts for verifiable execution. I'm getting surprised by the slides as you are. So if we go towards the most common application right now in AI, so AI agents, right? There's a lot of industry momentum there in crypto and outside of crypto, right? So we had Jensen Huang from NVIDIA predict that 2025 will be the year of agents, right? And I think that's great because agents are maybe a solution, that can help us bridge that UX gap that we have between Web 2 and Web 3, right? Because if people are used to using agents in Web 2, you can actually just, connect the Web 2 and Web 3 agents, and then, you don't have to teach people how to use wallets, how to use the apps. You can just they just need to know how to use that agent that talks to the crypto agents, right? So the start was very basic, right? You had simple chatbots, on Twitter that were funny, that were dunking on people. But we see how the space is evolving, right? And with handling more high stakes roles like DeFi, personal assistants, right? You need that security, that verifiability, and then it becomes crucial. Who's running the agent? Is the agent autonomous? And this is where the agent requirements come in, right? You want an agent that's private, that's trustless, potentially autonomous as well, depending on the application, right? But trustless agents, they need open, reproducible builds with verifiable execution results. Autonomous agents, require verifiable self-sovereignty control over the instance, right? And personal agents require private interactions, guaranteed confidentiality, temporal data processing, so you know that your data or your interaction is not getting out there for everyone to kind of see. If we look at what's the deployment, the ROFL and AI integration, right? You have an AI agent that you deploy in a ROFL app. You get privacy and verifiability through that, and we also integrated a key management system within the ROFL apps. So you also have a completely integrated key management system for secure asset holding by the agent, right? So right now we saw, I think it was, so you had AIXBT being hacked, I think a few days or a week back. You had, it wasn't a jailbreak. Here was actually a hack, I think, with AIXBT. But you also had, I think it was through Terminal, the first kind of AI agent where it was actually managed by a guy in the back, and he had full control to the keys and shuffled around the tokens that were sent to the trust through Terminal agent, right, or more of a chatbot, right? But these are kind of the core components that you want to have for an agent to be sure that security is not compromised. But of course, one is on the key side, but admin control is also very important, right? As I mentioned before, you have now projects slapping T's to it, just for the remote attestations, but it's important who has admin control, right? Who can change the policies. Of course, policy changes are visible on chain with us, right? You can put in safeguards like time delays or anything similar, right, to protect against that. But we have instances, of projects that just put stuff in the TE. There's no connection to any on-chain verifiability, and that is basically no different than running something in Asia, right? There's somebody else running this for you, right? It's in a secure environment, but if they can change the policy, how can you verify anything, right? Or they change the source code, they deploy in there. The attestation might still be true, but they change the source code, right? So the attestation is verified, right? It's really running that code, but it's a different code. And if you don't have, somewhere to check what was the attestation before and after, then you don't have really anything, right? So that's why governance here is also very important, right? And you have multiple options, right? You can have full autonomy where you give, transfer complete control to the agent. That's also risky, right? You don't know how the agent will develop itself. Maybe funds get stuck. So depending on the application, maybe that is the right solution or not. It's for everyone to decide for themselves. Then you can have DAO governance, right? Where you have votes that execute policy changes based on proposals. You can have multi-sig control, like with wallets, right? Or you can have single wallet control, but then maybe that's more for personal agents, right? Because for personal agents, there's less need for that trustlessness, right? Because you're running it, right? So you just need it to be secure. You don't have to be, you don't have to have it be fully autonomous or trustless, right? You need that trustlessness only towards the code. That's kind of the counterparty here, right? So wrapping up here, I think I'm going over a little bit over time, but yeah, the focus, for us, it's building, an AI augmented future, that shifts towards this distributed AI system. So shift to decentralization, a balance, between ASI and HSI, preserving cognitive liberty, and yeah, use Oasis and get involved. Visit docs at docs.oasis.io and start building. One less famous quote from Iron Man, right? So Human Torch is all about centralization because it's faster, right? But Iron Man knows his stuff, so decentralized is better because power to the people. Anybody wanting to get in touch? We have a forum on the website. You can reach me directly through email or Telegram or X, or just grab me here after the chat and we can talk. And that's about it. Questions? They're not mandatory, so I can go, no problem. Just if somebody. Okay, Giga. I'll give you the mic.
What do you think is the biggest hurdle for people being using blockchain?
Yeah, I think the comfort or discomfort is probably in the UX, right? So, for instance, we made a chatbot with a small model that you can deploy in a TDX, and when you ask it a question, you sign the transaction, wait for the block to fall, get the response. So the UX obviously is a little bit slower. It's a little bit more cumbersome, right? It's always like that, right? So the big Web2 companies have that, advantage of having really streamlined interactions. People don't really think about it. It's just second nature at this point. And crypto, you need to be a bit more intentional, right? It's the same with, cypherpunks in the past, when you wanted to be private, using DuckDuckGo, using Proton, being out of the Apple, Google bubbles, using custom ROMs on their phones, it's a hassle, right? So I think it's until we bring it, closer to the experience that they're used to, it's always going to be a problem. I think we can. Like Raffle can actually alleviate quite a few things because it's off-chain compute, so you can kind of have the verifiability be a little bit, how should I say, delayed, so you can get let's say a response, but then verification happens in the back. But yeah, I think it's more about UX, and obviously exploits are not helping us as well. So people thinking going into crypto, they're going to be losing money. Memes didn't help as well. Pure gambling. So it's all of that combined. It's like people are still a little bit deterred towards crypto, and then mixing with AI, maybe it's even worse. But I think if we're going to be building solutions, and we are heavily now working on the AI agent side, especially working on the frameworks for Verifiable AI agent in the DeFi space. We're going to be launching something fairly soon, so a little bit of alpha for you guys, but and you guys, but it's we see it as a very important sector, even though the kind of climate right now around agents deterred, in the past, let's say 3-4 months. I think they're going to have a comeback when they have more utility, and this is where we're building right now. Anything else? If not, thank you very much. That's it from my side. Oh, how was the presentation? Good, bad? Okay. There was a little bit of, I saw the text, yeah. You see, AI is not that capable yet.
This is good. Hi, I'm Philip, head of DevRel at Flare. So Flare is an EVM layer 1 blockchain, and apparently we're one of the guys that pretty much just slapped the ETH on the blockchain and said this should be enough to work. No, the thing is, we started in a bit of a different direction. So we started as an EVM chain, nothing special, wanted to focus on oracles, but slowly we saw that adding new things on blockchain, pretty much enabling blockchain to do something else than just being able to get you some tokens and being able to give you some security is really important stuff. So it's pretty much going to be a presentation how we went from a normal blockchain, a fork of Avalanche, and why adding these AI things is important, how you can achieve a reasonable way of having a trust in the AI model that's running somewhere, what do you need to do, what are the nitty-gritty details, and getting to the stage where we are now when we had a successful hackathon. So maybe just going back, at least in my opinion, I'm a mathematician. I would say I'm kind of new to this space. I've been here for like 3-4 years. And initially I was just laughing. So, and the main thing for me, what you get from blockchains is the security. That's the only thing. So if you need a blockchain, you're pretty much paying a lot of stuff for a very, very slow, very expensive database. So that's the only thing. And as soon as you're fine with that, it's okay. The problem is that until you get to that point, you pretty much think, okay, yeah, we got meme coins, we got tokens, we got this and that. But at the end, you're paying for security, either be it proof of work, and then we decided, okay, that's bad for environment, let's move to something else. Then it's proof of stake. But at the end, it's only this. You're paying for security and security costs. So whenever you want to deploy something on blockchain, whenever you want to do something there, there's always a trade-off. Should I do a lot of things off-chain and be happy with them and just a test of them on-chain? Or should I do them properly secure on-chain, do the whole computation off-chain, but then I can't do anything else? So that's pretty much it. It's always some sort of a balance between the security provided by the chain, security provided by all the validators running the same computation, being able to verify it, knowing that this has been done, and just running some model on AWS and saying, okay, fine, it's good. So it's pretty much this. It's striking a reasonable amount of balance. And what has this proven to be useful for? Where tokens, ERC, you name it. So small interactions between users, distribution to users. Let everybody have their own wallet. Let's pretty much use the fact that the banking system has been undeveloped for the last 30 years in Europe and be able to send somebody in Southeast Asia 20 USDT and don't worry about it. So those small things. there's DeFi, and the main problem with DeFi that blockchain had was that until we got AMM, you couldn't really do anything useful with DeFi on blockchain. So you can't have a proper order book on blockchain up until now. So there's a bunch of projects now that are trying to create a proper order book, but on a normal EVM chain, on pretty much anything that has to be synchronized across the whole world, you have to do something. You have to cheat a bit. So you need AMM for this. And the only other thing when you can really use the data from some external thing is this checkpointing. So you can use blockchain to have some supply chain assurance, so the holy grail. So use blockchain to store a very small amount, distribute this across this decentralized database, be sure about this, have this secure, and that's it. But those are the only things that we can currently use. So it's pretty much just having a settlement layer, having something that everybody agrees on, but those data pieces have to be small. So this is the problem that we started on. So again, normal EVM layer chain, you could do all these things, but it usually wasn't enough. We needed something else. That's why we decided to just start slapping T's on top of it and hope that this would magically solve the things. But it took us a bit of time, so we wanted to scale the computation. So how do you scale the blockchain if you already have it? So one way to do it is pretty much go the Solana way, and some people are going to hate me for this, but if you decrease the number of validators, it's pretty easy to scale things. So put them in the same data center, I don't know, have 3 of them, put them in Google BigQuery, and you're fine with it. It's going to be fast, it's going to be efficient, but the data center burns down and you're screwed. And pretty much everybody here knows what happened to parties because they forgot to add backups. So that's one thing. You can scale by removing this blockchain stuff. You can scale differently. You can use L2s, as we know, and then you post checkpoints to something else. So you leverage the ability to have data on some DA layers. You leverage the ability to just put checkpoints of data. But still, you have to do some computation somewhere else. You have to trust it, or at least you have to verify it at the end. So scaling both computation and memory, that was still a challenge. So what do you do? And you can go either way, and we still wanted to be reasonably decentralized. And it comes at the end to the consensus. So the same blessing and a curse you have at this point. So if you want 1,000 or 100 or 50 validators to know the same thing, if you want this to be accessible, well, you need this communication among all this. And even the Pectra upgrade pretty much talks about this. So we're going to lower the amount of validators in Ethereum by increasing the amount of Ether they can stake from 32 to between 32 and 1,024. And by doing this, we allow them to communicate a bit more among themselves. So pretty much, I mean, it's a simple mathematical problem. If you have n people communicating, you have a graph with n squared edges. And that's the problem. That's what it comes down to. So at some point, if you want to scale, if you want to have this in a decentralized fashion, if you want to have the data everywhere, and if you want to have everybody doing and verifying the computation, you run into a bunch of problems. And then also you need data availability layers if you're just checkpointing, and you need to pay somebody to do it. And you need, I don't know, if you're in the case of optimism, you need proofs, you need proofs and all this, and somebody has to be doing this, and you have to pay them somehow. And if you're a layer 1, that's kind of simple. You just print your own token and use it as a rewards, and yeah, for sure, somebody's going to do it. But this doesn't scale, and this doesn't pretty much take long to become problematic. So what we did, the first thing we did was we had a bunch of oracles on the chain. So this very specific oracle was called FDC, the Flare Data Connector, which allowed you to get deterministic data from other chains. It was pretty much asking our own set of validators a deterministic question. So has this Bitcoin transaction happened? And I'm sensing it has. This is the full output of a transaction. I'm going to hash this output. And then I presented this whole question to the set of validators and say, okay, this is the input of the query you should execute. This is the output I'm getting. Please confirm this for me. And the main idea behind this was that if you can achieve a consensus on which block is getting mined, if you can achieve a consensus on what transactions are included into it, you can also achieve a consensus on a deterministic query, what's happening somewhere else. And in our case, that started with Bitcoin. So, okay, has this transaction happened? And then we kind of evolved this. We said, okay, has this Ripple transaction happened? Can you index the Ripple XRP ledger beforehand? And can you say, okay, was the block, I don't know, 2,000 blocks ago empty? Can you say that no transaction such as this has happened? And again, the thing we did was we say to all the validators, please confirm this question for me. So this was the initial idea on how do you scale this. And along the road, we came to a problem that during the payments to one of the underlying agents, you have to say, okay, please pay me to this specific address. And this address was Bitcoin address. And if you've ever tried to validate Bitcoin address, Bitcoin public address in Solidity, it's painful. So there's this whole set of things you have to check. And doing this in Solidity is expensive, be very expensive. And if you code it yourself, the auditors are just going to kill you. So we decided to not do this computation on-chain. We decided to not add a precompile because messing with the node is also problematic. And we decided to extend this ability of what the FDC can do to add a new specific question. Can you compute this small thing for me? Can you run this small Python script that validates a Bitcoin address? And out of this, we saw that as long as you get validators to be able to respond to deterministic queries, you can increase this small Python code from a computation. Can you run this code for me? And then efficiently put just the result on chain and have all the machinery around it. You can increase this to ask validator, okay, can you run this Web2 query for me? And if you do it properly in a deterministic fashion, okay, can you ask weather.com with those two parameters, with this specific API key? What was the weather in Ljubljana on 21st of March at 8 p.m.? And if they get the same response, you've pretty much asked all of them to perform a computation similarly as if it was a precompile, and you know that all of them got it. And at this point, it was becoming quite clear that if we can extend this just a little bit more and decrease the amount of validators that need to run this, it's a nice way of keeping the network intact. So using the existing tools, using the existing EVM, using all the existing solutions that you already have, and just add a similar to precompile-like thing to your chain by leveraging the same set of validators. And importantly, every time you ask a question, you're assured that the same thing is getting the same response, A, and B, that the security of the answer to your question is the same as the block building itself, because you're asking the same validators. If they screw it up, it's the same as if they were to screw up the block building process. Yeah, I should have done this. Okay, and that's pretty much it. So when do you really trust a computation that's done by something else? So you can have a chain, you can have an add-on on-chain that does this, or you can answer a validator set, okay, please compute this for me. And if you have this reasonably prepared, if you have some sort of queries that can do this, you can create a really good parameterized way of asking external work. So you can go to Web2 APIs, and as soon as you can go to Web2 APIs and post-process them, you can pretty much output a custom Python script and let them compute it for you. You have some parameters you can tweak, and then you go. And what do you do? Well, the easiest thing to do this, the easiest thing to secure it is to pretty much use the stake. So now we just split the stake from the validators to use some stake for the validator itself for block building. And the second piece of stake is now also securing this additional querying the external world. Okay, we'll get to why this is important very soon. And now you're at the specific point where you say, okay, so now I have 100, 1,000, 500 validators doing the same thing for me. Can I make this a bit more efficient? Can I make the computations a bit more efficient in such a way that not everybody's doing the same thing, but I can still trust the result of the computation reasonably well? And TEs turned out to be a really good solution for this. So you could do a bunch of ML, you could do a bunch of things that are related to AI, even with our first thing, but you know that your computation has been done 100 times, which is kind of expensive. You're already on blockchain, so things are expensive. If you're on blockchain and you want to use an AI model somewhere else, you don't want to pay anything more than a normal invocation of an AI model, maybe one order of magnitude more, but not 2 or 3 orders of magnitude. So we need to find out what was the correct scale. And TEs were really good to do this because with them, if you create a system around them to allow people to easily attest to TEs, so that the TE is running the correct code, and it hasn't been changed, you pretty much have a chain, the validators in between that can attest to those TEs, and at the end, the result of the TE. So the whole chain of computations can be reasonably secured. And yeah, doing this is this final non-trivial thing. Oasis is doing, so how do you make sure that you properly attest to what TEs are doing? How do you make sure that the computation you are offloading to somebody else, in our case, whatever you have to do with machine learning, how do you make sure that this thing is really running? So each of the major cloud providers is providing you their own abstraction on top of it. So the main idea behind the TE is that the hardware provider gets you a certificate that this TE is indeed correct, that it can sign a bunch of stuff, and the TE can also sign what's happening in between. So in our case, what we did is we offloaded all this again to our validator set. So setting up a TE, getting these initial things correct, it's quite expensive. So, and by gathering the first few users that wanted to use this, we arrived at a specific problem that the users spent most of their time setting up the TE. So I've got the TE, I've got it running somewhere, I'm pushing some Docker on it. How do I now get the users of my dev to say, okay, I really trust that this TE is set up correctly, you're not leaking your private key, and how do I trust it that every time that code is changing, I'm getting somehow notified that things are moving away? Pretty much, how many of you have ever checked verified smart contracts that you're interacting with? Really? You've read all of them? The whole block scout thing? Just the main one? Yeah. So, and again, in that case, we arrived at the same conclusion. So you want to, again, leverage the validator set. So, and now instead of asking them, okay, execute this web query for me, execute this Bitcoin check for me, we pretty much, every time a new TE is set up, the same set of validators is again used to attest to this thing. So what this means is that we built an abstraction on top of existing cloud providers. So currently we support Google Cloud because that was the easiest one to get to support, and we already have a contract with them to use their hardware. So it was kind of like a no-brainer to start. And it was a nice layer of abstraction. How do you bring users from a fact, okay, I'm on blockchain, I can't do anything. I'm on blockchain, I can set up my own TE, just put everything there and pretty much screw with people and say, yeah, it's going to run there, please trust me, it's all right. To a state when you have a blockchain, a set of validators also attesting that this TE that's running somewhere indeed conforms to the same reasonable state of security that we have for blockchain, and the users, the developers only being able to start with the TE, get some instructions to it, run it, and constantly verify that this is happening. And by using the validator set, you abstract this away from developers so that anyone can at any time check, okay, is this TE still responding to the same command as before? Has the Docker been changed? So the code that you can deploy in TEs can be pretty much an arbitrary code. There are a few caveats there. But you want to make sure that your chain as such is making sure that nothing nefarious is happening there. Okay, so this is how the first iteration of this integration looked like. So this is a picture from a smart wallet, but the generic TE is very simple. I just couldn't find a nicer image. So the thing is, the most important thing is that whenever you're sending the instructions to a TE, you want to leverage the same thing you leverage on a blockchain. So if your TE, if the AI model you're running off-chain needs to listen to a blockchain to get some instructions, or needs to listen to any other blockchain to get the instructions, your first problem is that this thing you're running is going to get bloated. You need a light client for a chain, and pretty much none of the chains have a working light client, which means that the thing you need to do is have an RPC in your TE or have your model connect directly to the RPC. You need an RPC in our case for Flare. You're connecting to Ethereum to execute some actions there. You need another RPC, which is problematic from two things. First one is, A, you need to include this. You're paying a bit more for the TE. And secondly, all the instructions you get to your model are now conditionally secure by the fact that there might be a bug in the RPC you're running locally. So the thing we did, and this kind of proved useful for all the things that people were using after this, was that we abstracted away the instruction part, again, to just be executed on behalf of the validators. So again, you don't have to run an RPC inside the between. You pretty much are just working on behalf of the instructions contained into the smart contract directly on chain. So pretty much, again, the validator set, instead of just being the validator set, is now also signing a bunch of other instructions, which are very cheap. But in this way, you can make these things much, much smaller and allow people at that point to deploy just a model, which was the holy grail. So what we wanted to do was to come to a stage when you are deploying just a single extension of a blockchain, and now you can really do just AI as a single instruction in your smart contract. This was the holy grail that we wanted to achieve. So how do you make a smart contract that calls a model? The model executes, you verify what the model is, and you're done with it. And there's a bunch of problems you have to solve in the middle. So how do you set this up? How do you solve the key sharing? One of the big problems is that TEs always come with their own private key, which is amazing for AI agents, which is amazing for anything you want to interact with users. But the thing is, if the TE shuts down, you're screwed. If you have a wallet controlled by this, you're screwed. If you have a Twitter account controlled by a TE and the TE shuts down, you're again screwed. So creating a nice abstraction over this allows the user, the developer, again, to pretty much just push instructions to it, and you are the one that's making sure that all this works in the end. And the third thing that was also important and gave us quite a bit of problems, specifically on the hackathons, is this information leakage. So you have a TE, you have a model that's running in it, and very nice, the people are happy because you're getting a bunch of private information inside it. You're getting the model to run on a confidential information. You're getting the model to run on a bunch of healthcare information. And at some point, these things can start to leak. So how do you make sure that the TE is alive for only that specific time? And how do you make sure that the code inside is so simple that it's easy to verify, not just for the person that's working on it, but also for the person that's trusting it with data? So this is also another thing why you want to make those things as simple as possible. As soon as you add in another node, another RPC, another RESTful API so people can easily connect to it, you pretty much have 100 lines of code that is running your model and 2 gigabytes of additional code that's just there for a bloat. And somewhere in there's going to be a problem. So those are all the steps that we had to take to come to a place when you can now have a blockchain with a off-chain compute where you can run anything else. And obviously now we were able to finally start with the funny AI stuff that can really be useful. So we just had a hackathon with Google, technically Google Cloud. They're being recorded. Okay. So we just had a hackathon with Google Cloud. Find me afterwards. And the main idea was, what can you do with a model that's running on a blockchain so you can trust that the output of a model is getting saved to somewhere safe? And secondly, you know that the model cannot change in between. So this opened the world for a bunch of stuff, and specifically most of the people opted directly for AI agents. Why? I'm going to have an AI agent that can run something on my Twitter account, and the main thing that I don't want it to happen is for this agent to change its mind in between. So the main thing that you want it to be is the fact that I'm always continuously attesting to the code, and if anything goes wrong, the blockchain itself can shut down this other precompile. So this was an important consideration. How do you continuously attest to this, and how do you make sure that the users can pretty much forget about this? So we've had a bunch of different projects, and specifically most of them focused on those two things. So you have a nice AI model that's running somewhere, and you can trust it with your private keys because those are always encrypted. And you also have an AI model that can access your banking or your past credit data, because again, you know that the TE is going to shut down after each invocation, which allows us to have a simple models that calculate your credit score and shut down. Why is that good? It's much better than a long-running model. It's much better than a long-running machine that you attach to an existing system, because all the verification can be done much simpler. So all the auditing you need is much, much simpler, because you pretty much have to know that this one-shot thing is not going to leak any information. And as soon as you're done, your information is erased. So this was also one of the main considerations when thinking about adding AI availability to the chain, is how do you make them one-shot and how do you make them auto-destruct immediately? And yeah, that's mostly it. So maybe just to recap, so starting with the blockchain, what can you do to extend the blockchain with these small pre-computes that can do things that blockchains usually cannot do, or you can only do them if you're running this in a cloud? So how do you make a small burst of computations that can be efficiently encoded? And how do you make these small bursts still correctly private? And yeah, that's it.
You have a lot of vendors making computing something. How, to what extent is it scalable? So how much power single time we have? We have any performance tests for this already, or?
No. So the thing is, you don't scale the TEs. What you scale is this communication. So you scale TEs just to a level where you're fine that the TEs are reasonably live. The thing where the validators come into play is this information passing to them. So TEs are kind of like an extension. So instead of having a blockchain with 1,000 validators, you have 10 TEs or 50 TEs to perform your computation. You trust them that for that limited time, they can't be exploited. You trust them that for that limited time, the attestation holds, and then you shut them down. So you don't have each validator run their own TE, because that is pretty much the same as if each validator was to run the same model. That's kind of useless. And plus, the greater the amount of those TEs, the more problematic it becomes for a private data. So the more private you want to keep the data, the less TEs you have. So for the things that are one shot, just compute something on my credit data, give me a score, and then die, you want just one TEs, because you're fine with this computation not getting executed fully if something bad happens, than with having this data across multiple TEs if there's an exploit on one of them. So that's the abstraction level you bring the users to. So create a wallet for me. I want multiple TEs. I'm going to shard the key. Create a one-shot, compute something on a legal data for me. I'm just going to get one. I'm going to compute something on it. If something goes wrong, it's erased anyway. I'm not going to have this scaled across 10 TEs because it's expensive and possibly problematic.
So TEs on the side of
development. No, TEs are provisioned by us and attested by us, but the requests for them come from developer, yeah. Pretty much app specific. There's no other questions, speeches there.
Thank you, Philip. Thank you, Philip. Thank you. We have some drinks now, pizza. For anyone that is not part of the meetup group, it's not so. And thank you, enthusiasts. Yeah, you can also scan the QR code and it will direct you directly to our website. Thanks.